Hi everyone, this is Lisa. Because we're going to need to talk about educational statistics in class this week and going forward, I thought that I would just put together a few quick little films that could help people review common statistical methods that are used in TK through 12 settings. I know what you're thinking. You're thinking, Lisa, statistics in my credential program? Well, they're not going to be very complicated, but they might be unfamiliar. But the bottom line these days is that schools really prefer hard data over any kind of anecdotal evidence or narratives or reports of personal experiences. And hard data means quantitative information. And analyzing and interpreting quantitative information typically requires the use of statistics. Well, I'm definitely not a statistician, but I feel that it would be beneficial if we could all establish some shared understandings of these concepts, which would give us common language to talk about the content we're going to be discussing in the next couple of weeks in class. So, but the statistics we're dealing with are pretty basic, and it's possible that you may already have mastered them or you're very familiar with them. So this fun size film focuses on the mean and distribution around the mean, but if you're already familiar and comfortable with these terms, you don't have to watch this movie unless you want to. So the mean is the average score that's earned by a group of test takers. Imagine that you have 4 students and they take a 40-point quiz. You get their scores, which you can see lined up here. You add them all up, you divide by the total number of scores, and you get the average, or the mean, which is 34. Interestingly, none of the students actually earned a score of 34. 34 is the mean, which is also sometimes called the mean score. And if you look in the third row down, you'll see the black line that represents the mean. And the mean is the average score for this particular group of test takers. So classroom teachers can use mean scores in many different ways, but the one that came to mind for me first was imagining a single subject history teacher, perhaps, who has 3 sections, first, second, and third period. And he gives all 3 sections the same quiz, and in his prep period, 4th period, he computes the mean score for each period. And then he compares the mean score for first period, second period, and third period. And he hopes the mean scores from each period will be high, meaning that the students, have demonstrated high levels of mastery and understanding of the content that he taught. And he also hopes the mean scores will be similar to each other. Meaning it would be, if you have if first and second period have means in the low 90s, and third period has means in the mid 80s, then there's something that's not going right there in third period. And this teacher would have to think about, is he just pooping out in third period? Like Louis said, sometimes the third, if you're teaching sequential courses in a row, the last one always seems to fall to pieces. Maybe the student's behavior is inappropriate. Maybe there have been a lot of absences because you have people who are in the marching band who are competing and they leave. Doing that kind of analysis of the data enables teachers to really take responsibility for their students' performance and their success, and that's one of the kinds of ways that teachers might use mean scores. There are a lot of different ways that a group of students could take a 40-point quiz and end up with a mean score of 34. it would depend on how many students were in the class, the variation in their capabilities, and so on. So sometimes knowing the mean isn't enough, and you need to start looking at the distribution of the student scores around the mean, because that provides important information in the data interpretation process. So here we're looking at two different tables that plot scores on the same quiz. And they both have a mean of 34, but the distributions around the mean look very, very different. So when we're looking at the table on the top, you can see that there's a very, very large gap between George's scores down here in the mid-20s and Ringo's perfect score up here. That's a pretty large spread. And when you look at the table beneath the one we were just looking at, you can see that there's not such huge variation in the scores of the different students. So that's just an example of how you can interpret those information. What we're seeing here with the Beatles is what's called a wide distribution around the mean. The mean score for the group is 34, but there are 14 points that separate the lowest score from the highest scores. And that kind of distribution suggests that the test takers' levels of skill and mastery are varied significantly. And if I were the teacher of this group, I would be very certain to come up with ways to differentiate instruction, to keep Ringo and John learning and on task, perhaps give them some sort of activity that would require them to apply what they know to a real-world problem, something like that. And I would also work hard down here with George to help him connect with the concept and master it. So this is a time when you would really benefit from offering differentiation. This chart is shows a narrow distribution around the mean. And the mean is the third row down, and on my iPad the color looks kind of like Santa Clara burgundy claret wine kind of color. So the students are close to each other relatively in their scores. There's only 4 points separating the lowest score from the highest score. That's quite different from the previous graph. And so this narrow distribution around the mean indicates that there's less variance in the students' knowledge of the content that was being tested in the quiz. And even though the lowest score is a 32, that's not an especially low score. So perhaps as the teacher, I might want to check in with Brian and Bill to find out, maybe to review their tests with them to find out if they have any questions and so on. So the key points to remember about the mean and distribution around the mean is that the mean score is a numerical average that provides some info, but not all the info about student performance. And whenever possible, you want to look also at the distribution of scores around the mean, because that enables teachers to see big picture trends in the data, to identify the students who need additional support, and to identify the students who need added challenge or enrichment. And I wish I had some sparkle fingers that you could see me waving, or some snap, snap, snaps that you could hear. Oh, can you hear that? Okay, maybe you can. So I'm going to go on. I'm making 2 more of these little films today, and they're all for you. So you can look forward to them. Bye.